On February 4, 1971, the British Prime Minister received a phone call that changed everything. Rolls-Royce was finished. Not struggling, not downsizing, bankrupt. The most prestigious engineering name in British history, the company that built the Merlin engine that won the Battle of Britain, the company whose name was synonymous worldwide with mechanical perfection, could not pay its bills. The cause was a single jet engine called the RB211 and a contract with Lockheed Aircraft that had spiraled so far out of control that no amount of government money could patch the hole. The bankruptcy nearly took Lockheed down with it. It triggered emergency phone calls between London and Washington. It forced the British government to nationalize the company overnight, the first major nationalization by a conservative government in modern history. And the most painful part of all? The engine worked. It was revolutionary. It just cost too much and arrived too late. But to understand how Britain's greatest engineering company arrived at that moment, you have to go back to 1863, to a small village called Alwalton, near Peterborough, where a boy named Frederick Henry Royce was born into a family that could not afford to keep him alive. If you find this journey through Europe's lost industrial glory interesting, hit that like button and subscribe to the channel. We cover the forgotten factories, estates, and fading legacies of Europe every week. Let's start at the beginning. Chapter 1. The Boy from Alwalton. The story of Rolls-Royce does not begin in a factory. It begins in poverty. Frederick Henry Royce was born on March 27, 1863, in Alwalton, a tiny village in the English countryside. He was the youngest of 5 children. His father, James Royce, ran a flour mill leased from the local church. The business was failing before Henry could walk. When the mill finally collapsed, James Royce was declared bankrupt. Under the laws of Victorian England, that meant prison. Henry's father was locked up for debt, and the family disintegrated. They moved to London with nothing. By the age of 9, Henry Royce was working. He sold newspapers on the streets. He delivered telegrams in the rain and cold. He contributed every penny to a family that could barely feed itself. By the time he turned 15, he had completed exactly 1 year of formal schooling. Not 1 year of secondary school. 1 year total. Then something shifted. An aunt recognized something in the boy, some restless intelligence, some obsession with how things worked. She scraped together enough money to pay for an apprenticeship at the Great Northern Railway workshops in Peterborough. For the first time in his life, Henry Royce had access to tools, to machinery, to the world of engineering. He was immediately and obviously in his element. His natural skill with materials, his eye for precision, his ability to understand machines almost by instinct, all of it emerged in those workshops. But 2 years in, the money ran out. His aunt could no longer pay the apprenticeship fee. Royce was back on the streets. He did not stop. He moved to London and took a job at the Electric Lighting and Power Generating Company, one of the earliest firms wiring Britain for electricity. He attended evening classes in mathematics and English after work. He taught himself electrical engineering from borrowed books and sheer repetition. The company went bust. Royce, still only 19, found himself unemployed again. So, in late 1884, with £20 in savings, which is roughly equivalent to £2,500 today, Henry Royce founded his own business, F.H. Royce and Company, based in a small workshop in Manchester. He started by making battery-powered doorbells. Then he moved to overhead cranes and heavy industrial equipment. The cranes earned a reputation for quality that spread through the north of England. The business grew, but by 1901, foreign competitors from Germany and America were undercutting British electrical manufacturers. Royce's health was failing from years of overwork and poor nutrition, damage that had been building since childhood. A doctor told him to get outside, buy a car, take some air. Royce bought a French-built Decauville motor car. He was appalled by its quality, so he took it apart, studied every component, and rebuilt it from scratch. Then he decided to build his own car entirely, not to compete in the automobile market, simply because he believed he could do it better. In 1904, the first Royce car rolled out of his Manchester workshop, a 10-horsepower, 2-cylinder machine. It was quiet, smooth, beautifully finished, and mechanically superior to almost everything else on British roads. The boy who had sold newspapers in the cold had just built one of the finest cars in England, and the right person was about to notice. Chapter 2. The meeting that changed everything. On May 4th, 1904, two men sat down together at the Midland Hotel in Manchester. One was Henry Royce, a self-taught engineer from poverty who had never completed school. The other was Charles Stuart Rolls, the Eton and Cambridge-educated son of a baron, a wealthy London car dealer who imported and sold French automobiles from his Mayfair showroom. They came from different worlds entirely, but they shared one thing: an obsession with mechanical excellence. Henry Edmonds, a mutual friend who owned one of Royce's first cars, had arranged the meeting. He showed Rolls the Royce car beforehand. Rolls, who normally preferred 3- and 4-cylinder engines, was stunned by the quality of Royce's 2-cylinder machine. It was better than anything he had been importing from France. By the end of the meeting, they had a deal. Royce would build the cars. Rolls would sell them. Every car would carry both names: Rolls-Royce. In 1906, the partnership was formalized as Rolls-Royce Limited, with shares offered on the stock market to raise £100,000 for expansion. That same year, Royce designed a completely new model, the 40-50 horsepower model, later named the Silver Ghost, for its metallic appearance and its engine that was as quiet as a phantom. British journalists tested it and called it the best car in the world. Orders flooded in from across Europe, India, and America. The Silver Ghost was not just a good car, it was a statement of philosophy. Royce insisted that the chassis be tested under extreme conditions before it left the factory. One early demonstration model was driven 15,000 miles in a reliability trial organized by the Royal Automobile Club. At the end of the run, inspectors found that the total cost of replacement parts needed to restore the car to as new condition was just over £2. £2 for a car that had been driven the equivalent of crossing the Atlantic and back. The company needed a bigger factory. After considering sites in Manchester, Coventry, Bradford, and Leicester, it was Derby's offer of cheap electricity that sealed the decision. Royce himself helped design the new factory, a 12.7-acre site on the southern edge of the city, with purpose-built workshops arranged to Royce's specifications. He designed the production flow. He chose the machinery. He set the standards for the inspection process. Every car that left the factory did so because Royce, directly or indirectly, had approved it. On July 9, 1908, the Derby factory opened with a formal ceremony. Rolls-Royce had a permanent home. Within 3 years, proof of the Silver Ghost's reputation arrived from an unlikely place. The Indian government ordered 8 cars for use by King George V during the Delhi Durbar of 1911. Royalty was buying what a bankrupt miller's son had built. In 1921, to meet surging demand, Rolls-Royce even opened a second factory in Springfield, Massachusetts, where nearly 3,000 more cars were built over the next decade. But tragedy arrived fast. Charles Rolls was also a pioneer aviator. He had met the Wright brothers, flown with Wilbur Wright, and became the first person to make a two-way crossing of the English Channel by air in June 1910. 1 month later, on July the 12th, 1910, his modified Wright Flyer crashed at an air show in Bournemouth. The tail section failed. Rolls fell 100 feet. He was killed instantly. He was 32 years old, the first Englishman to die in a powered aircraft. Royce was devastated, and then his own health collapsed. In 1911, doctors discovered he had severe intestinal illness and gave him months to live. He survived, barely, but was forced to leave the Derby factory permanently. He moved to the south of England and spent winters in southern France, directing all engineering work remotely. Every drawing, every design, every new plan still had to pass through his hands personally. His famous instruction to the company, the phrase that would define Rolls-Royce for the next century, was simple: strive for perfection in everything you do. Take the best that exists and make it better. That obsession was about to meet its greatest test, because a war was coming, and Rolls-Royce was about to transform from a car company into something the world had never seen before. If you are finding this story of lost European industrial glory interesting, hit that subscribe button. We have much more to cover, and this factory's story is just getting started. Chapter 3. The engine that won 2 wars. The original partnership agreement between Rolls and Royce contained a line that most people overlooked. It stated that the company's purpose included vehicles for use on land, on water, and in the air. Charles Rolls had believed in aviation from the very beginning. He had tried repeatedly to convince the company to build aircraft engines before his death. That vision was realized not by choice, but by necessity. When the First World War broke out in August 1914, the British War Office came knocking on the Derby factory door. They needed aero engines, and they needed them immediately. Rolls-Royce initially resisted, worried that licensing production to other manufacturers would compromise their quality standards, but the pressure was overwhelming. Within months, Royce had designed the company's first aero engine, the Eagle, a 12-cylinder, 27-liter power plant that drew directly on the engineering principles of the Silver Ghost car engine. The Eagle produced 250 horsepower in its early versions, and it powered the Handley Page heavy bombers that struck German positions from the air. It also powered the Vickers Vimy biplane that made the first non-stop transatlantic flight in June 1919, piloted by John Alcock and Arthur Whitten Brown from Newfoundland to Ireland. Rolls-Royce had gone from building luxury cars to crossing the Atlantic. After the war, the company pursued aviation records with increasing intensity. The Schneider Trophy, an international seaplane speed competition, became Rolls-Royce's proving ground through the late 1920s. The company developed the R engine specifically for the 1929 and 1931 races. In 1931, a Supermarine S-6B seaplane powered by a Rolls-Royce R engine won the trophy outright at 340 miles per hour. Weeks later, the same aircraft broke 400 miles per hour, the first time any aircraft had reached that speed. The R engine was a monster. It produced over 2,000 horsepower from a supercharged V12 design, and it was the direct ancestor of the engine that would change the course of the Second World War. Henry Royce's last major design project, begun before his death in April 1933, was a new V12 aero engine. It was first run on a test bed on October 15, 1933. Following the company's tradition of naming engines after birds of prey, it was called the Merlin, after Britain's smallest falcon. That name would become legendary. Here is how the Merlin worked. 12 cylinders arranged in a V formation at 60 degrees, liquid cooled with ethylene glycol rather than water, which allowed for smaller, lighter radiators. A displacement of 27 liters, supercharged to force more air into the cylinders at altitude, where the atmosphere thins and engines lose power. The early Merlins produced just over 1,000 horsepower. By the end of the war, advanced variants were pushing past 2,000. The supercharger was the secret weapon. Stanley Hooker, a mathematician who joined Rolls-Royce in 1938, redesigned the supercharger's intake and impeller system to dramatically improve efficiency at low altitudes, exactly where the Battle of Britain would be fought. Hooker's modifications gave the Spitfire and Hurricane an extra 22 miles per hour of speed. In a dogfight over the English Channel at 300 miles per hour, 22 miles per hour was the difference between life and death. The Merlin had one notable weakness. Unlike German engines that used fuel injection, the Merlin relied on a carburetor. When a Spitfire pilot pushed the nose into a steep dive, negative gravity forces would temporarily starve the engine of fuel, causing it to cut out. German pilots learned to escape by simply nosing down. British pilots countered by rolling inverted before diving, keeping positive forces on the carburetor. A young engineer named Beatrice Schilling eventually designed a simple restrictor device, nicknamed Miss Schilling's Orifice, that largely solved the problem. But none of it mattered without production at scale. This is where the Derby factory system became truly extraordinary. Ernest Hives, the general works manager at Rolls-Royce in Derby, understood before almost anyone in Britain that war was coming. In the late 1930s, he organized a network of shadow factories across the country, each with its own Merlin production line. Derby alone produced 32,377 Merlins. Crewe built 26,065. Glasgow built 23,675. Ford of Britain built 30,428 at a factory in Manchester. And across the Atlantic, the Packard Motor Car Company in Detroit produced 55,523 Merlins under a license contract worth $130 million. In total, 168,000 Merlin engines were built by the end of the war. At peak production, a new Merlin engine was rolling off assembly lines somewhere in the Allied world roughly every 30 minutes, around the clock. They powered the Supermarine Spitfire, the Hawker Hurricane, the Avro Lancaster, the de Havilland Mosquito, and the North American P-51 Mustang. More than 40 different aircraft types used the Merlin across every theater of the war. It powered the fighters that won the Battle of Britain in the summer of 1940, the darkest weeks of the entire conflict, when fewer than 3,000 pilots stood between Hitler's Luftwaffe and the invasion of England. It powered the four-engined Lancasters that struck deep into Germany night after night. It powered the long-range Mustang escorts that finally gave Allied bombers the protection they needed all the way to Berlin and back. The Merlin even found a second life on the ground. A derivative called the Meteor was adapted for use in tanks, powering the Cromwell and later the Centurion, which many military historians consider one of the finest tanks ever built. The Merlin has been called the engine that won the war. That is not exaggeration. Without the Derby factory and its shadow network, the Battle of Britain could not have been fought. The strategic bombing campaign could not have been sustained. The air superiority that made D-Day possible might never have existed, and the company was only getting started. Chapter 4. The Jet Age and the Golden Peak. The war ended in 1945. But for the Derby factory, the next revolution was already underway. During the war, Rolls-Royce had begun developing jet engines in parallel with piston engine production. Frank Whittle had demonstrated the first British jet engine in 1937, and Rolls-Royce recognized the future immediately. Their early turbojets, the Welland and the Derwent, entered production in 1944 for the Gloucester Meteor, the first British jet fighter to see combat. Then came a decision that Rolls-Royce would later regret. In 1946, the British government authorized the sale of Rolls-Royce Nene jet engines to the Soviet Union. The thinking in Whitehall was that the Soviets would take years to master the technology. They were wrong. Soviet engineers reverse-engineered the Nene within months, producing copies designated the Klimov FivK-1. Those copies powered the MiG-15 fighter that shocked American and British pilots in the skies over Korea in 1950. British jet technology was shooting at British allies, powered by an engine designed in Derby. It was a strategic blunder that reshaped Cold War defense policy for decades and taught every Western government a lesson about sharing military technology with potential adversaries. But Rolls-Royce pressed forward. Through the 1950s, the Derby factory became the undisputed center of British jet engine innovation. The company developed a series of increasingly powerful and efficient engines, each building on the lessons of the last. The Avon powered the English electric Canberra bomber and the de Havilland Comet, the world's first commercial jet airliner. The Dart turboprop became one of the most successful aero engines ever produced, powering the Vickers Viscount, which sold over 440 aircraft and opened the jet age for short-haul airlines around the world. And then came the breakthrough that truly changed everything. In 1960, Rolls-Royce introduced the Conway on the Boeing 707 and the Douglas DC-8. The Conway was the world's first bypass turbofan engine to enter commercial airline service. A turbofan works by routing a portion of air around the engine core rather than through it, which improves fuel efficiency and reduces noise dramatically. The Conway represented a fundamental shift in how jet engines worked, and Rolls-Royce had gotten there first. The Spey engine followed, designed for shorter-range aircraft. It powered the BAC-111, the Hawker Siddeley Trident, and later the Fokker F-28. Reliable, efficient, and profitable. In 1966, Rolls-Royce acquired Bristol Siddeley, their only remaining domestic competitor, which brought the Olympus engine used in Concorde, the Pegasus engine for the revolutionary Harrier jump jet, and a deep bench of engineering talent based at Filton near Bristol. By the mid-1960s, Rolls-Royce engines were installed in aircraft operated by more than 200 civil airlines and more than 100 armed forces around the world. The Derby factory was the capital of British aerospace. Tens of thousands of people depended on it for their livelihoods. The company name was recognized globally as shorthand for the absolute pinnacle of engineering, and that reputation, that towering confidence in their own superiority, was about to become the most dangerous thing about them. Chapter 5. The Dark Side of Perfection. Henry Royce died in 1933, but his obsession with perfection did not die with him. It became embedded in the culture of the company like a strand of DNA, passed from generation to generation of engineers in the Derby factory. Every component inspected by hand, every tolerance held to the tightest specification, every shortcut rejected. The philosophy was simple. If it could be made better, it had to be made better. No exceptions. For decades, this culture produced extraordinary results. The Merlin engine, the Conway, the Spey, engineering achievements that placed Rolls-Royce in a category of its own. But perfection has a shadow. And by the 1960s, that shadow was growing. The first problem was insularity. Rolls-Royce had spent so long being the best that it had developed an institutional allergy to outside ideas. The company promoted almost exclusively from within. Its senior engineers had often spent their entire careers in the Derby system. They trusted their own judgment above all else because that judgment had been validated again and again for 60 years. The second problem was the gap between engineering brilliance and commercial competence. The people running Rolls-Royce understood engines better than almost anyone alive. What they did not understand, and what they dangerously underestimated, was the financial mechanics of fixed-price contracts in an era of rapidly escalating technology costs. In the military world, where Rolls-Royce had built most of its experience, cost overruns could often be absorbed. Governments needed engines. Delays were inconvenient but rarely fatal. The customer was a nation, not a corporation. If a program ran over budget, negotiations happened, supplemental funding appeared, timelines shifted. The relationship between engine maker and government was more partnership than pure commercial transaction. In the commercial aviation world of the late 1960s, the rules were entirely different. Airlines were negotiating harder than ever on price. Delivery deadlines were tied to aircraft programs worth billions of dollars. Competing engine manufacturers in America, General Electric and Pratt & Whitney, had vastly more experience with commercial airline customers and understood the ruthless mathematics of these deals in ways that Rolls-Royce simply did not. American engine makers had been selling to American airlines for decades. Rolls-Royce was trying to break into that market for the first time with the biggest gamble in its history. Miss a deadline in this world, and the penalties could destroy you. The third problem was a critical loss of leadership. In July 1967, Adrian Lombard, Rolls-Royce's chief engineer and the person most likely to have steered the company through its next great challenge, died unexpectedly. He had been the engineering brain behind the company's jet engine program, the person who understood both the technical ambition and the practical constraints. His death left a vacuum in leadership at exactly the moment when Rolls-Royce needed it most. The company that prided itself on perfection was about to discover that perfection in engineering does not protect you from catastrophic failure in business. If you are enjoying this deep dive into one of Europe's most important industrial stories, hit that like button. It really does help the channel, and there's much more to come. Chapter 6: The RB211 Gamble. In 1966, American Airlines announced that it wanted a new, wide-body airliner. Something bigger than the Boeing 707, smaller than the 747, capable of carrying 250 passengers across the United States. Two manufacturers responded. Douglas Aircraft proposed the DC-10. Lockheed proposed the L-1011 TriStar. Both designs needed engines, and both needed a new generation of power plant, a high bypass turbofan far more powerful, more efficient, and quieter than anything in service. The competition came down to three engine makers: America's General Electric, America's Pratt and Whitney, and Britain's Rolls-Royce. For Rolls-Royce, this was the opportunity of a generation. They had been shut out of the Boeing 747 program, losing to Pratt and Whitney. The British government had pulled out of the Airbus A300 project, killing the larger RB207 engine. The TriStar was the last door open into the American wide-body market. If they lost this competition, Rolls-Royce risked being permanently locked out of the most lucrative segment of commercial aviation, so they swung for the fences. The engine they proposed, designated the RB211, was revolutionary in three ways. First, it used a three-spool design. To understand why this mattered, you need to understand the basic physics of a jet engine. Air enters the front, gets compressed, mixed with fuel, ignited, and the expanding gases blast out the back, producing thrust. The compression stage is critical. You need to squeeze the incoming air to extremely high pressure before it reaches the combustion chamber. In a conventional two-spool engine, two groups of compressor blades connected by two concentric shafts handle this compression. The problem is that each group of blades has a different optimal rotation speed. Running them both on just two shafts means compromise. Neither set of blades operates at peak efficiency. Rolls-Royce's solution was to add a third spool, a third concentric shaft with its own set of compressor blades. Three groups of blades, each spinning at its own optimal speed, each doing its job at peak efficiency. The result was an engine that could produce more thrust per unit of fuel consumed than any two-spool design of comparable size. It was more complex to build, it was more complex to maintain, but aerodynamically it was superior. This three-spool architecture would eventually become Rolls-Royce's signature technology, the foundation of everything they have built since. Second, the RB211 promised to use a brand new material for its fan blades, a carbon fiber composite called Hi-Fill, developed at the Royal Aircraft Establishment in Farnborough. Carbon fiber fan blades would be dramatically lighter than titanium alternatives, giving the RB211 a significant power to weight advantage over General Electric's CF6. Third, the engine operated at higher temperatures and pressures than any previous Rolls-Royce design. The fan was over 7 feet across. The gas temperature inside the turbine section reached 1,250 degrees Celsius, 150 degrees higher than the Conway. At those temperatures, the nickel alloy turbine blades lost 25% of their strength for every additional 25 degrees. Each blade required dozens of tiny cooling holes, drilled with microscopic precision, then heated white-hot and squeezed between dies to achieve their final shape. An engineering nightmare. On March 29, 1968, Lockheed announced orders for 94 TriStars and placed an order with Rolls-Royce for 150 sets of RB211 engines. The agreed price was £230,375 per engine, fixed price. Rolls-Royce had committed to a delivery date, a performance guarantee of £42,000 of thrust, and a price ceiling, all on an engine that existed only on paper. Every major decision that followed cascaded from this single moment. Chapter 7. The Collapse. Almost immediately, the RB211 program began to unravel. By autumn of 1969, the engine was in serious trouble. During test runs, it produced only 34,000 pounds of thrust, £8,000 short of the guaranteed £42,000. It was overweight. Its fuel consumption was too high. When Stanley Hooker, the legendary Merlin engineer who had been coaxed out of retirement to help with the program, examined the engine, he found that the high-pressure turbine efficiency was running at just 65%. The three spools were spinning at speeds far from their design values. Then came May 1970, and the moment that sealed the company's fate. The high-fill carbon fiber fan blades, the technological crown jewel of the entire program, were subjected to the mandatory bird strike certification test. Engineers at the Derby facility fired a 4-pound chicken carcass into the spinning fan blades at takeoff speed. The blades shattered. High-fill, the material that was supposed to give Rolls-Royce an unbeatable advantage over General Electric, failed the most basic safety requirement for a commercial jet engine. The thin leading edges of the blades could not absorb the impact. The carbon fiber composite delaminated on contact. Rolls-Royce had been developing titanium fan blades as a backup, but switching to titanium meant more weight, which meant less thrust, which meant the engine fell even further behind its performance guarantees. The titanium blades also brought their own manufacturing nightmares. Engineers discovered that only one side of each titanium billet had the right metallurgical quality for blade fabrication. Half the raw material was unusable. By September 1970, Rolls-Royce reported to the British government that development costs for the RB211 had risen to £170.3 million, nearly double the original estimate. The cost of manufacturing each engine now exceeded its selling price. Rolls-Royce was losing money on every engine it was contractually obligated to deliver. Meanwhile, the Lockheed TriStar had been designed exclusively around the RB211. The aircraft's S-duct inlet for the center engine was sized specifically for the RB211's dimensions. Lockheed could not switch to a General Electric or Pratt & Whitney engine without a complete redesign of the airframe. The two companies were locked together, falling together. On February 4, 1971, Rolls-Royce was placed into receivership. Trading in Rolls-Royce shares ceased on the London Stock Exchange. The most prestigious engineering name in British history could not pay its debts. The news hit Derby like a bomb. For most of the city's working population, Rolls-Royce was not just the biggest employer, it was the identity of the place. Families had worked in the factory for generations, grandfather to father to son, building engines that flew around the world with the letters RR stamped on them. Suddenly, none of that mattered. Thousands of jobs hung in the balance overnight. A trade union shop steward captured the feeling of the workforce when he said they were fighting the Battle of Britain all over again. In Parliament, Labour Member of Parliament Tony Benn called it a major national tragedy and a grave blow to confidence in the country. Workers held emergency meetings at company sites across England, from Derby to Bristol to Hucknall, trying to understand what had happened and what came next. A Member of Parliament from Derby described the workforce as a unique team and a national asset that must not be broken up. The employees' financial losses were not limited to their jobs. Many Rolls-Royce workers owned shares in the company through employee savings schemes. Those shares were now worthless. Personal savings that had been accumulated over years of service vanished. The same morning, the receiver walked through the factory gates. Prime Minister Edward Heath's Conservative government faced an impossible choice. Heath had built his political identity on refusing to rescue failing industries, what he called lame duck companies. He had specifically campaigned on the principle that the government should not prop up businesses that could not survive on their own. But Rolls-Royce was not a struggling textile mill. Its engines powered Royal Air Force fighters and bombers. Its jet engines flew with NATO allies across Europe. More than 100 air forces depended on Rolls-Royce for spare parts and maintenance. And the RB211 contract was entangled with Lockheed, an American defense contractor of enormous strategic importance. If Rolls-Royce went down, Lockheed might follow, and the political fallout between London and Washington would be severe. Heath nationalized the company. It was an extraordinary political reversal. A conservative prime minister who had promised never to rescue failing industries was now buying one with public money because the alternative was unthinkable. The government created a new entity called Rolls-Royce 1971 Limited and purchased the aero engine, marine, and industrial gas turbine divisions. The car division, profitable but now financially insignificant compared to the engine business, was set aside for separate disposal. The purchase price was not even fixed immediately. The government acknowledged that without a continuing business, many of the assets might be worthless. They simply took control and promised to sort out the accounting later. The priority was keeping the factories running, keeping the military contracts alive, and keeping the RB211 program from dragging Lockheed and half the Western defense industry down with it. The original Rolls-Royce Limited, the company incorporated on March 15, 1906, the entity that Royce and Rolls had founded in partnership, was placed into formal liquidation on October 4, 1971. It remains in liquidation to this day. Over 55 years later, the legal entity that once represented the pinnacle of British engineering still exists, only as an entry in the company's house register, slowly being wound down. Across the Atlantic, Lockheed scrambled for survival. The company's TriStar program was entirely dependent on the RB211. There was no alternative engine that could fit the aircraft without a complete redesign of the airframe. If the RB211 died, the TriStar died with it. Lockheed sought $250 million in federal loan guarantees from the U.S. Congress. The debate was fierce. Critics argued that the government should not be in the business of rescuing private companies. Supporters argued that losing Lockheed, one of America's largest defense contractors, was a national security risk. The Senate vote to approve the guarantees passed by a single vote. The TriStar program survived, barely, but delays caused by the Rolls-Royce crisis gave the rival DC-10, powered by General Electric engines, a critical head start in the market. Lockheed would eventually build only 250 TriStars against a break-even target of 500, losing $2.5 billion on the program, equivalent to roughly $9 billion today. Lockheed never built another commercial airliner. The company retreated entirely into military contracting, and it eventually became Lockheed Martin. One engine contract. Two companies brought to their knees on opposite sides of the Atlantic, and the people of Derby left wondering whether the factory that had built the engines of two world wars would ever recover. Chapter 8. What came after? The government now owned Rolls-Royce, but the RB211 still needed to be finished. Kenneth Keith was appointed chairman of the new nationalized company, and his first call was to Stanley Hooker. Hooker was one of the most remarkable engineers in British aviation history. He had first joined Rolls-Royce in 1938, had redesigned the Merlin supercharger that helped win the Battle of Britain, had worked on every major wartime engine, had then moved to Bristol Siddeley, where he led the development of the Pegasus engine for the Harrier jump jet, and had officially retired. He was in his 60s. He came back anyway. Hooker assembled a team of other retirees, engineers who had worked on Rolls-Royce engines for decades, men who understood these machines at an instinctive level that no amount of fresh recruitment could replace. Names like Cyril Lovesey and Arthur Rubra, veterans of the Merlin program who had solved seemingly impossible problems 30 years earlier, came out of retirement alongside Hooker. It was as if the ghosts of the Derby factory's greatest era had returned to save its future. They went to work on the RB211's problems systematically. The high-pressure turbine efficiency was painstakingly improved. The spool speeds were brought into alignment. The titanium fan blades were refined into a workable design that could pass the bird strike tests the high-fill blades had failed. Slowly, methodically, with the kind of patient engineering discipline that no amount of money can substitute for, the engine began to deliver on its original promise. On April 14, 1972, the RB211-22 received its type certification. 12 days later, the first Lockheed L-1011 TriStar entered commercial service with Eastern Airlines. The engine that had destroyed its maker was finally flying passengers. Hooker was knighted in 1974 for his role in saving the program. He later remarked, with the dry humor typical of British engineers, that working on the RB211 had taught one famous banker that £50 million was peanuts. The RB211 did not just survive, it thrived. Rolls-Royce continued developing the engine throughout the 1970s and the 1980s, increasing its thrust from the original £42,000 to over £60,000. The RB211-524 variant was selected for the Boeing 747, breaking the American monopoly on wide-body engine sales. British Airways found that their 747s fitted with RB211s burned roughly 7% less fuel than aircraft using Pratt & Whitney engines, saving over $1 million per aircraft per year. The RB211-535 powered the Boeing 757, and when American Airlines placed a major order in 1988, citing the engine's low noise as a deciding factor, it marked the first significant order from a U.S. airline since the TriStar debacle. The engine had completed its redemption. Meanwhile, the car division followed a separate path entirely. In 1973, Rolls-Royce Motors was separated from the nationalized Aero Engine Company and returned to private ownership. It was sold to Vickers in 1980. Volkswagen bought it in 1998, but BMW secured the rights to the Rolls-Royce name for automobiles. Since 2003, Rolls-Royce Motor Cars has been a wholly owned subsidiary of BMW, manufacturing cars at a new factory in Goodwood, not Derby. The car brand that Henry Royce built in a Manchester workshop now belongs to a German company. In 1987, Margaret Thatcher's government privatized Rolls-Royce, returning the Aero Engine Company to the stock market as Rolls-Royce plc. The government retained a golden share to prevent a hostile takeover, ensuring that this strategic national asset could not be bought by a foreign competitor. And the RB211's engineering DNA lived on. In 1989, Rolls-Royce renamed a variant of the RB211-524 as the Trent, launching an entirely new family of engines that would become the backbone of the modern wide-body fleet. The name Trent, after the river that flows through Derby, was deliberately chosen. It connected the future of the company to its home. The Trent 700 powers the Airbus A330. The Trent 800 powers the Boeing 777, the Trent 900 powers the Airbus A380, the largest passenger aircraft ever built. The Trent XWB powers the Airbus A350, one of the most fuel-efficient long-haul aircraft in service today. The Trent 1000 powers the Boeing 787 Dreamliner. As of 2026, Rolls-Royce is the world's second largest manufacturer of aero engines, behind only General Electric. The company that was bankrupt in 1971 now builds engines that carry millions of passengers across every ocean on Earth. Every one of those Trent engines traces its lineage directly back to the three-spool architecture of the RB211. The same fundamental design that shattered carbon fiber fan blades in a Derby test cell in 1970. The same design that cost more to build than its selling price. The same design that brought down one of the oldest and most respected companies in British history. The engine that killed the company became the engine that built the future. It just took 20 years, a nationalization, a privatization, and several generations of patient engineering improvement to prove it. If you have made it this far, you clearly care about these stories of Europe's lost industrial power. Consider subscribing. We have a deep library of content just like this and much more coming. Chapter 9. The Legacy in the Walls. Walk through the Rolls-Royce campus in Derby today, and you are standing on ground that has been continuously used for engine manufacturing for over 115 years. The original Nightingale Road factory, partly designed by Henry Royce himself, still exists. Its marble hall, the grand entrance lobby of the 1912 commercial block, has been preserved. But the scale of what happens around those historic buildings has changed beyond recognition. Rolls-Royce's production test facility in Derby is one of the largest and most advanced civil aerospace manufacturing complexes in the world. More than 1,000 people work directly in that facility alone, building, assembling, and testing Trent engines for the world's biggest aircraft makers. The total years of combined service among the Derby production test facility workforce exceeds 15,000 years. Some of these families have been building Rolls-Royce engines for 3 generations. In 2021, Rolls-Royce opened Testbed 80 in Derby. It is the largest enclosed engine test facility on Earth. It is over 130 meters long, built from 3,450 tons of steel and 27,000 cubic meters of concrete, with an intake tower standing 29 meters tall and an exhaust stack at 37 meters. The test cell can handle engines weighing up to 66 tons. It features real-time X-ray imaging that allows engineers to visualize the position of seals and clearances inside an engine while it is running at full power. In July 2024, the facility completed its first engine test run. Across all of Derby, approximately 15,700 people work for Rolls-Royce. Another 10,300 work at other Rolls-Royce sites across the United Kingdom. The company is still the city's largest employer by a wide margin, just as it has been for over a century. And after years of struggle, the company has entered what may be its strongest period since the 1960s. But that strength was earned through one more near-death experience. In 2020, the COVID-19 pandemic collapsed global air travel almost overnight. Rolls-Royce's business model depends heavily on engine flying hours, collecting revenue every time one of its engines is in the air. When airlines grounded their fleets, Rolls-Royce's income fell off a cliff. The company announced it would cut 9,000 jobs, roughly 20% of its global workforce. In Derby alone, 1,500 positions were eliminated. The company raised £5 billion through equity sales and debt to survive. For the second time in its history, the factory in Derby faced the real possibility of extinction. And for the second time, it survived. Under CEO Tufan Ergin, who took over in January 2023 and described the company as a burning platform that needed urgent transformation, Rolls-Royce has undergone a dramatic turnaround. Costs were cut, underperforming divisions were restructured or sold. The share price has risen from roughly £1 to £11 in 3 years, one of the most extraordinary recoveries in British corporate history. The company is now valued at approximately £90 billion, making it the fifth largest company in the FTSE 100 index. Operating profit targets originally set for 2027 were hit 2 years ahead of schedule. Revenue reached £15.4 billion in 2024, with underlying operating profit of £1.6 billion. Rolls-Royce is also building small modular nuclear reactors for power generation, positioning itself for the energy transition in ways that Henry Royce could never have imagined. But here is the quiet detail that almost nobody talks about. The original Rolls-Royce Limited, the company incorporated on March 15, 1906, the entity that Charles Rolls and Henry Royce founded together over a handshake at the Midland Hotel in Manchester, is still in liquidation. It entered voluntary liquidation on February 4, 1971. It has never been dissolved. Over 55 years later, the legal shell of Britain's most famous engineering company still exists in a state of permanent winding down. The factory rebuilt itself. The name survived. The engines kept flying. But the original company never came back. Chapter 10. 6 Lessons from a Broken Engine. 6 Lessons from the Rise and Fall of Britain's Greatest Engine Factory. Lesson 1. Engineering. Perfection does not equal business competence. Rolls-Royce built the finest engines in the world. No serious person disputed that. The Merlin won the war. The Conway invented the turbofan. The RB211's 3-spool architecture was genuinely ahead of its time, but none of that engineering brilliance translated into an understanding of contract risk, cash flow management, or the financial consequences of promising a fixed price on unproven technology. The people who understood engines did not understand money. And in 1971, money won. Lesson 2. Fixed price contracts on revolutionary technology are death sentences. Rolls-Royce committed to delivering a revolutionary engine at a fixed price of £230,375 each, based on a design that existed only on paper, using materials that had never been tested in commercial aviation, and at performance levels that their own test runs could not initially reach. When development costs doubled to £170.3 million and each engine cost more to build than its selling price, the mathematics became inescapable. The company was contractually obligated to deliver a product that would bankrupt them with every unit shipped. You cannot fix price a revolution. Lesson 3. Single customer dependency is an existential risk. The RB211 was designed exclusively for the Lockheed TriStar. The TriStar was designed exclusively around the RB211. If either company failed, the other would follow. When Rolls-Royce went into receivership, Lockheed nearly collapsed with it. When the TriStar underperformed commercially, selling only 250 units instead of the 500 needed to break even, the market for the RB211 was permanently constrained. Rolls-Royce survived only because the engine was later adapted for the Boeing 747 and 757. That adaptation happened after the crisis, not before it. The dependency nearly killed them both. Lesson 4. A culture of secrecy prevents early warning. Rolls-Royce's engineering culture prized internal expertise and distrusted external oversight. Problems with the RB211 were known inside the company long before they were reported to the government or to Lockheed. The carbon fiber blade failures, the shortfall in thrust, the cost overruns, all of these issues were visible to senior engineers well before the crisis became terminal. But the same culture of perfection that drove extraordinary engineering also created an environment where admitting failure felt unthinkable. The company's people believed they could fix anything if given enough time. They were right about the engineering. They were fatally wrong about the money. Lesson 5. The thing that nearly kills you can become your greatest asset. The RB211 destroyed Rolls-Royce. Then it saved Rolls-Royce. Once the engine was finally certified and entered service, it proved to be exactly what its designers had promised: a quieter, more efficient, more powerful engine than anything the competition offered. Its three-spool architecture became the foundation for the entire Trent family of engines that today powers a significant portion of the world's long-haul airline fleet. The engine that cost everything ultimately gave back everything, but only because the British government was willing to absorb the loss and give the engineers the time to finish what they started. Lesson 6. Legacy is not what you build, it is what survives you. Henry Royce was born into poverty, never completed a year of schooling, and died in 1933, having built one of the most respected engineering companies in history. He never saw the Merlin win the Battle of Britain. He never saw the jet age. He never saw the RB211, or the bankruptcy, or the nationalization, or the recovery. But his factory in Derby is still there. His engineering philosophy is still there. His name is still on the engines that fly millions of people across the world every day. The original company he founded is still, technically, in liquidation. The car brand he created belongs to a German corporation. The Aero engine company was nationalized, privatized, restructured, and nearly destroyed by a global pandemic before staging the most dramatic comeback in British industrial history. The boy who sold newspapers on the streets of London at the age of 9 left behind a factory that has been building engines for 115 years. He never made it past 1 year of school. He never had a childhood. He barely survived his own success, working himself to the edge of death before he was 50. But the thing he built in Derby, the culture of relentless improvement, the insistence that every component matters, the belief that perfection is not a destination but a direction, that thing outlived him by nearly a century. It survived the death of his partner. It survived 2 world wars. It survived bankruptcy, nationalization, privatization, pandemic, and the kind of corporate near-death experience that would have destroyed any company without something deeper than money holding it together. The ghost of Henry Royce's obsession still lives inside those walls in Derby. The turbines still spin, the test beds still roar, the engines still fly. That is what it means to build something that outlasts you. And that is the story of how Britain's engine empire lost its roar, found it again, and is still, after all this time, reaching for perfection. Thank you for watching. If this story moved you, hit the subscribe button and check out the video on screen now. I will see you in the next one.